Okay, so today we're going to discuss the remaining topics here, or the species included in the Sporozoans. Okay, so we have here again as a review of the classification. Okay, we have here the kingdom Animalia, we have here the subkingdom Sporozoa, we have also here the phylum Apicomplexia. This includes here your class Sporozoa. This includes here the subclass Coccygia and subclass Pyroplasma. So under your subclass of Cygia, this includes here the Plasmodium. Alongside with your malarial parasite, we have also here the Toxoplasma, we have also the Isospora, we have also here the Cyclospora, we have also here your Isospora, and we have also here the Cryptosporidium. On the other hand, for the subclass Pyroplasma, we have here your Babesia. And we have also here the phylum Microspora. This includes here your other species here. That includes your Microsporidium. We have also your Blastocystis and Cephalozoon, Nosema, and the other one, Encephalozoon. Then we'll be discussing also here the unknown classification, because this one is more of the fungal-like organism. We have here your Pneumocystis gerovesi, or your Pneumocystis carinii. Okay, we start your discussion with your Babesia. So we have here the Babesia, basically transmitted by the bite of your ticks belonging to the genus Exodus. So we have here the three species of your Babesia. We have here Babesia microti. So that one is transmitted here by Exodus damini and Exodus scapulans. Try to cause here hemolytic episode, and it would resemble here the fever manifested with your malarial infection. I've also here the Babesia bigemina, transmitted here by the tick ripicephalus. So try to cause here Texas cattle fever. Then we have here the Babesia divergens, transmitted here by the bite of Exodus racinus. Okay, for the life cycle of your Babesia, so it almost resemble here the life cycle of your malaria. So this one would also have the schizogony in the intermediate host, and sporogony also here in the definitive host, which are your vector. So basically, again, you get infected by the bite of the ticks. They try to introduce the sporozoids. The sporozoid enter the red cell. Unlike in your malarial infection, so punta mo na siya sa liver bago sa red cell natin. But here, they try to invade directly your RBC. And within the RBC, the sporozoid will transform to become trophozoid, multiply, and until it try to become your merozoid. The merozoid will eventually get out or release out of the red cells, try to rupture the merozoid, go to your bloodstream. Then here comes again here the next vector. We try to take blood meal, so it try to bite the infected patient. What it gets here would be your merozoids, which eventually develop already in the gametocytes. The gametocyte, that's what will be ingested by your vector. And once inside the body of the vector, the gametocyte will be converted, would undergo here the fertilization, when we just have their micro and the macro gametes develop here to become your zygote, okinete, developing to become oocysts, and oocysts multiply to become or rupture to produce the sporozoids. The sporozoid will go to the salivary gland of your Exodus, then the life cycle goes on. Okay, we have here the morphology of the parasite. So again, the parasite would have a characteristic trophozoid within the red cell of the infected patient. So it would have here the ring stage on that. So this would be characterized by blue cytoplasmic circle, which are interconnected, with also the very prominent the vacuous. Then the merozoid would be able to form here a tetrad. So each of that would have here the pear shape or pointed ends, and that would enable here to form a Maltese cross. So Maltese cross is characteristic of your Babesia. So how does your Babesia differ here with your malarial infections? So this would have the absence of the blood pigments or the hemozoin, plus the absence also of your steeplings. Wala siyang Schaffner's dot and other steeplings. And then also have here the absence of large growing trophocytes. Okay, the next one we have here the Isospora belli. So this one, the infective stage would be the oocyst. The oocyst is described here as ovoid in shape. This one would have here double cell wall. Then would have here, as it's try to mature, it try to form here two sporoblasts. Dalawang ganyan. But then eventually, the sporoblasts as try to mature, magiging sporocysts. Okay, there are two sporocysts and each of this one contain here four sporozoids. Okay, for the life cycle, so you get infected by ingestion of contaminated food and water containing the oocysts that's being shed on the stool of the infected patient. Then go to your MES. Okay, then eventually try to sporulate here, try to release the sporozoids from your oocysts. Diba itong oocysts? So, lalabas itong mga sporozoid once inside your intestinal mucosa. Then eventually try to develop here to become your merozoids, which further develop here to become your gametes, the micro and the macro gametes. Undergoing fertilization, form here the zygote. So magiging ano na siya, oocysts ulit. Then the oocysts here are shed on the feces of the infected patient. Okay, for the disease pathology, so this would have here characterized by malabsorption syndrome with excessive fats present as stool in the form of steatorrhea. The patient also have here diarrhea and would have here the loose na stool. And we have here for the diagnosis, so basic identification of the characteristic oocysts. You could perform here the direct fecal smear. You could also have here the duodenal aspirate. You could also have the entero test, just like in the Jarcha. You could also have concentration technique to better recover the oocysts. You could have here the zinc sulfate flotation technique. You could also have the sugar sheeters test. And we have also here your acid-fast bacilli. So you could have here your auramine rhodamine stain for that, for the permanent stain with your immunofluorescence technique. Okay, the next one we have here the Sarcocystis. So we have the Sarcocystis hominis. The intermediate host for that would be the cattle or the mga beef. Then we have also here the Swiss hominis wherein the pig is the intermediate host, whereas the humans serve as the definitive host. Sarcocystis lindemani on the other hand, the intermediate host here would be the human. Okay, so the same life cycle as compared with your Isospora belli, and the infected stage is also the oocysts. Only that you get infected here not by coming from ingestion of the contaminated food and water with the oocysts, but rather you get infected here by eating of undercooked meat containing here the oocysts, or you call it once a sarcocysts. So the oocysts are found here on the meat of your intermediate host or definitive host. So the oocysts here the sarcom into say muscle. So that's it would resemble here the oocysts with your isospora, only that one is much smaller compared to the isospora. Okay, the next one we have here the Cryptosporidium parvum. Okay, just like your Isospora belli, the Cryptosporidium parvum is also associated here with the AIDS patient. Okay, so the infective stage for your Cryptosporidium parvum would also be the oocysts, but this one again, just like the Isospora belli, could also be found here the stool of the patient. So this is a gastrointestinal tract infection, where the parasite try to inhabit here the gastrointestinal tract. Unlike in your Sarcocystis na sa muscles natin, or sa muscles siya ng definitive host. Okay, so the oocysts differ only here with meron siyang oocysts, but then again, wala siyang sporozoids. Ay, wala siyang sporocysts. And each of the oocyst here still contains 4 na sporozoids. Only that, wala siyang sporocysts. With the presence also here of 1 to 6 dark granules, and the schizones would have here 4 to 8 na merozoids. For diagnosis, identification of the oocysts could be made here by your direct fecal smear, could also be by your entero test, could also concentration technique, could use still of your zinc sulfate and your sugar sheeters concentration technique, which are your flotation technique. And we have also here your acid-fast bacilli. Okay, with your auramine, rhodamine, and so modified quinones method. Okay, the next one, we have here the Blastocystis hominis. So this is the most commonly parasite associated here with the stool sample, especially for those patients having the gastroenteritis. So there's a transition here with the classification of your Blastocystis. So the first one has been identified here as an algae, but later on nagiging yeast, but later on classified as parasite, then straminophils, then parasite ulit. I think this one is already considered now as intestinal parasite already. Okay, so there are three forms for the Blastocystis hominis. We have the vacuolated form, we have also the granular form, and we have also here the amoeboid form. Of all the three, yung pinaka-common, usually present as stool sample would be the vacuolated form, characterized by a large vacuole here which try to push. Okay, the nuclei here at the peripheral side. Approximately there are 4 to 8 nuclei on that. Okay, then we have here usually associated with the co-infection with your Entamoeba histolytica and Giardia lamblia. So if that's the case, most likely this one is associated with the pathogenicity of that infection related here to the presence of your Blastocystis hominis. Okay, the next one we have here the Cyclospora cayetanensis. So this would have here the symbol with the morphology and even the life cycle of your Cryptosporidium parvum, only that the patient tried to manifest here diarrhea which tried to last here for more than 3 weeks, long-lasting diarrhea. Okay, and another difference here would be again, this is not also associated with the HIV patients or the immunocompromised patient. Another one would be the infective stage, the oocyst. This one will be described here as the oocyst having 2 sporocysts, and each of that one would have only here 2 sporozoids, and like in your Cryptosporidium parvum, there are 4 not sporozoids. Okay, then we have also here that, okay, you could identify the oocyst here by either, okay, the specimen here or the stool sample should not be formalin fixed, and then it's try to sporulate at room temperature. And the better recovery of that with the use of your trichome stains. You could have your 5% potassium dichromate. You could also have here your acid fast stain for identification. Okay, next we have here your phylum Microspora. So this includes here, again, these are just the fungal-like organisms. That includes here the 5 genera. We have Encephalotozoon, Encephalitozoon. We have your Flystofora, Nosema, we have also here the Microsporidium. So the first 3 genera here are actually associated with the ACE. Okay, so your Encephalotozoon associated here with the enteritis, the gastroenteritis. Your Encephaloffolitozoon and Flystofora associated with severe tissue inflammation. And the Nosema and Microsporidium associated here with the corneal infection. So they have here the spores, making them here as a fungal-like organisms, where they serve here as their attachment organ to infect the host cell. Once they try to attach to that, they try to release here their infectious material in the form of your Sporoplasma. Okay, the next one we have here the Toxoplasma gondii. So this one, the cat serve here as a definitive host and or any feline species. So humans serve here as the intermediate host. We get infected here, human get infected here by number 1, because of accidental ingestion of the cat feces. Second one, because of the ingestion here of the muscles or tissues containing here the bradyzoids. Okay, and we have also here the infective stage. And we have here congenital infection with a mother to child infection, very common during the 2nd, 3rd trimester pregnancy. And it would have here the effect of the abortion. We could also have your congenital defects in the form of your epileptic seizures. It could also be transmitted here by blood transfusion. Okay, then we have here the stages of the trophozoite. So we have here the intracellular. So within our intestinal tissues here, like they assume here rounded in form. Okay, and we have also here the extracellular, the free form here. Usually, they try to assume here the crescentic in shape. And that one will have here the nucleus found here on the rounded ends.